Hello, today I'm presenting a FM synthesizer implemented on the Texas instrument MSP432. I chose this project at the end of the microcontroller technology course at the Erfahren University of Applied Science. Stay tuned, as I will present a little demo song I made at the end. Now a bit of history. FM synthesis is a very popular method of creating sounds for music and effects. The iconic Yamaha DX7 was one of the first commercially viable and affordable FM synthesizers. The sound of the DX7 dominated the music of the 80s. But even now, FM synthesis is still very popular. It is used heavily in all kinds of EDM genres. One very notable example is dubstep, which pushed FM synthesis to its limits. So what even is FM synthesis? How do we do it? FM synthesis is a way of modulating sound waves in order to create a complex timbres. In a normal sine oscillator, the wave simply travels up and down with a speed congruent to the selected frequency f. In FM synthesis, you simply add another wave inside the wave, which has a frequency of k times f. Here is a quick live demonstration of the modulation. As you see, the blue and green waves are identical at the moment. This is because our modulation factor C is currently 0. If I increase C, you can see the wave starts deforming. The more I increase the factor C, the more crazy it gets. Multiplying the modulator frequency by higher factors makes it even crazier. Now you can see why FM synthesis became so popular. Only with 2 sine oscillators you can create incredibly complex sound waves, and nothing stops you from chaining even more waves. The implementation of this is not incredibly complex. The heart of the synthesizer is the simple chaining of waves. I only added some features that made it work like a real synthesizer. I added RDSR curves and the ability to understand MIDI signals. The MIDI signals are received over the serial interface. Initially I tried connecting an Arduino Micro with the chip over UART, so that the Arduino can act like a real USB MIDI device. But I had problems correctly setting it up, so instead I used software on the PC to send MIDI signals over serial to the board. The main challenge in this project was writing code that can run fast enough on the chip. Due to the limitations of the chip, I restricted the synthesizer to 2 operators with 4-note polyphony in total. Without modulation, I can do sustained 3-note polyphony. If I add 1 modulation, this shrinks to 2-note sustained polyphony. But I can still play 3-note in short bursts. If I use 3 modulations, I can only play 1-note sustained. However, higher numbers are still possible in short bursts. All the parameters of this instrument are controlled over MIDI. Using a DAW, I programmed the MIDI and recorded the output of the instrument over an aux cable. I took the liberty to add some drums, to layer some of the outputs, and to add some small effects like sidechaining, EQ and reverb. Enjoy the demo. This project was mostly successful in my opinion. Sadly, the chip was not fast enough to support all the features I implemented. In a future version of this project, the usage of integers instead of floats could be explored, as the ARM Cortex-M4F architecture allows for SMID operations with integer values, which could speed up the processing overall.